Alright, AB Calculus students, going to get into this review. Going to do the first 30 here, starting with these limits. Good advice here, try direct substitution first, and then if you get 0 over 0 or infinity over infinity, then you can maybe factor or use L'Hopital's rule. We didn't know L'Hopital's rule at the very beginning of the year when we were doing these, but of course we do now, so we have that at our disposal. Here, there isn't even a denominator here, so I'm just going to plug in the negative 2 and get 4 minus 10 plus 4 is negative 2. Here, going to plug in the 2, 8 over 0, that does not exist. Plug in the negative 2 here, and I get 0 over 0. That is an indeterminate form, which means I have to do more work. Here I could either factor and cancel, and I put the negative 2 in now, I get negative 4. Or I could use L'Hopital's rule. Derivative of the top is 2x, derivative of the bottom is 1, plug in the negative 2 and you get negative 4. So either way, both work. Here, there was, way back in section 2.5 maybe, there was a rule that we learned, a fact, that the limit as x approaches 0, sine x over x is equal to 1, so 3 times that would be just 3. If you don't remember that, that's fine, you can use L'Hopital's rule, because it starts off as a 0 over 0. So derivative of the top, 3 cosine x, derivative of the bottom, and when I plug 0 into that, I get 3 times cosine of 0 is 3 over 1, get 3, either way. Same thing here, this was a little fact I'm going to pretend I don't remember, so I can plug in 0, I get 1 minus 1, that's 0 over 0, so this is L'Hopital eligible. The derivative of negative cosine is positive sine over 1, and that is 0. Right, this is first 5. Limits to infinity, sometimes I think our book called this limits at infinity. Kind of funny to use the at there because you can't really get there. So this is about highest degree, top and bottom. That is what's going to win. Highest degree here is on the bottom, so that's going to be 0. Highest degree here, it's a tie, so it's going to be the ratio of the coefficients. Highest degree here is on top, so that's going to be, you could say positive infinity or it does not exist. Both okay. Here the highest degree is on the bottom and it's going to negative infinity. So let's see, for sines, this would be when I raise negative infinity to the odd power, that's going to give me negative, and the biggest thing on the top is also going to be negative, so that's actually going to go to positive infinity. But if you say does not exist, that's okay. If you did have two choices of positive or negative infinity, it would be positive, because both the leading degrees on top and bottom are going to yield a negative number. Here, I think I said that these were both the same, but they're not. This one's going to negative infinity, and this one's going to positive. So that goes to positive infinity. So infinity plus infinity minus, oh, wait a minute. Hold on. So I guess the trick here, the trick here is this is going to infinity faster than this is. I don't know if you remember like the ranking of things going to infinity. We don't really deal with factorials in AB calculus. It's something that comes up later in the year in BC. We do have exponentials, so like e to the x, and then we have polynomials like x to the n power, and then we have natural logs. So in the race to infinity, e to the x gets the gold, or some number to the x, and then any kind of polynomial thing comes in second. And Natural log x goes to infinity as x goes to infinity, but boy, it is tragically slow. So this one is dominating the negative infinity coming from this. And this, if x is going to negative infinity, this actually is going to go to 0, because that's the same as 1 over e to the x. And then this is the highest power. After that, that's going to be negative infinity to the odd power is negative times the negative, so that is also going to go to positive infinity. Both of those. Number 12, limits from a picture. If both sides are coming into the same place, then the limit is that, so this limit is 3, right? Getting closer and closer to 3. It does not matter that the point is in the wrong place. That it is discontinuity, this is the kind that you could fix, because we could just say, never mind that point, let's put it there. This is a vertical asymptote, so you could say that the limit here is positive infinity, or you could say it does not exist. And here, the limit as x approaches 2 from the positive side, that means from over here, it's 3. As it approaches 2 from the negative side, looks like we're at 2. And if those two things don't agree with each other, then the limit as x approaches 2 does not exist. But f of 2 is equal to 3, because that's where the point is. That is a jump discontinuity. Vertical asymptote, hole. Oh, and here we go. Types of discontinuities. There's your jump. There's your hole, and also in this graph we should include vertical asymptotes. That's a type of discontinuity also. All right. Types of non-differentiability. Well, if you're not continuous, then you cannot be differentiable. So any kind of discontinuity, like can't take a derivative there. This one is continuous, but there's a sharp corner, so can't do it there because the two sides don't agree. You got one slope on one side, and then it immediately transitions to another on the other side. And then if just for an instant the function achieves a verticality, like this is something like the y equals cube root of x function, then that's also a place where you don't have a derivative. For what values of a and b is a function continuous and differentiable? If it's going to be continuous, that means when you plug 2 into both of these things, they have to be equal to each other. So plugging 2 into this, I get 4 minus a, would have to be equal to plugging 2 into this, 2b minus 8. I've seen many students object to plugging 2 into this because there's no equal sign there. But fact of the matter is that the point and the hole have to link up. So plugging 2 in here, even though there's no equal sign, is like determining where the hole is. And if that point and the hole aren't in the same spot, then it's not continuous. So that has to be true. And then the derivative of this, g prime of x, is going to be equal to 2x when x is less than 2, and b when x is greater than 2. Notice I did not include the equal sign here because I don't know yet that it's differentiable. It might not be differentiable there. So you do not get to automatically carry the equal signs over when you take the derivative of a piecewise function. All right, so here, so 2 times 2 is 4. There's math for you. 4 equals b, and when I plug that in here, I get 8 minus 8, so a is also 4. I think that's good. So we could double check that. I'm just gonna to make sure. Don't want mistakes in my videos. 4x minus 8. When x is greater than 2. Okay, so when I plug 2 in here, I get 0. When I plug 2 in here, I get 0. That looks good. And then when I have the derivative here, that would be 2x and 4. Yep, that looks good. Check. The intermediate value theorem, that's the one that says if you have a continuous function that goes from here to here, it's got to cross every single horizontal line between whatever the y value is of this point and whatever the y value is of this point. Got to cross every horizontal line. So what do we have here? We have f of x continuous 2, 4, differentiable on 2, 4. So f of 2 equals 6. And f of 3 is equal to negative 2. And f of 4 is equal to, back up to 6 again. So it's dipping all the way down here and then back up again. And it's continuous and differentiable. It doesn't actually have to be differentiable to be able to use this. The thing that must be true, and sometimes in free response questions we have to say these magic words. If you want to invoke the I, V, T, then function must be continuous. Does not need to be differentiable. Right, must be continuous. Okay, so how many solutions are guaranteed? It's got to cross 0 if we say solutions to f of x equals 0. Twice, because it's going from positive 6 to negative 2, so it's got to cross everything in between, including 0, and then cross it again on the way back up. Does f of x equals 2, does f of x equal 2 for a value of x? 2, yes, because of the intermediate value theorem. Can f of x equal 8? Sure, it could, possibly, but we don't know that it does. There's no guarantee. I mean, the function could turn up and then come down and then go back up. It's possible. We don't know that it does, because 8 is not in between the y values there. Here's a page of a whole bunch of derivative rules. I think I mentioned to everyone that I gave this to that conspicuously missing are the derivatives of sine inverse and cosine inverse. And the College Board's very favorite thing, tangent inverse. Those, so you can add those there if you haven't already. There's the product rule. Let's try it. So the product rule says, I actually do it, usually I do this one first. I take the derivative of the first. So I'm going to do that. Derivative of the first is 2 times x plus 3. Chain rule multiplied by the derivative of what's inside, but that's just 1. So I'm all set there. Plus the first times the derivative of the second. Want to simplify that? Go ahead. I'm not really feeling it right now for the simplifying. So if you needed to, if you need to match that up to a multiple choice answer, then you could do that. How about the quotient rule? So quotient rule is low d high minus, I'm just doing that to remind myself that the chain rule is a thing. Low d high minus high d low over low low. Want to simplify? Probably not too much that you can even do to that. Chain rule, so the derivative of sine of whatever's behind there, the derivative of sine of whatever is cosine of whatever times the derivative of what's inside. Right? derivative of an inverse. This is the little game where we say, okay, if A is a point on the inverse function, I'm going to move up here. Here's F inverse. If 10 is a point on the inverse function, then there must be something you can plug into this to get 10. And I promised you that it would always be nice numbers that you could try, because this is kind of a guess and check game, especially if you don't have your calculator. It looks like 2 would work. 2 cubed is 8 plus 2 is 10. So now that means that the derivative of this function here and the derivative of the inverse here are related. They're reciprocals of each other, because rise over run turning into run over rise when we do the inversion. So that means if I just take the derivative of this, f prime of x is equal to 3x squared plus 1. So f prime of 2 is equal to 13, which means that f inverse prime of 10 is 1 over 13. Oops. Sorry about that. And let's see, we're at 21. Same idea. I'm going to have my f inverse. So I want to know slope of the inverse at 2, so there must be a point something comma 2. So let's see what I can plug in here. If I plugged in 1, no. Plug in 2. Yep, that looks like that does it, right? Because 2 times 4 is 8 minus 6. So it's the point 2, 2 on both. That's kind of boring and potentially confusing. So the derivative is 4x minus 3. So f prime of 2 is equal to, that's the 2 I'm plugging in, is equal to 5. So that gives me over here 1/5. Is this. All right, finding some derivative rules, using some derivative rules. Let's say with. All right, so product rule here, h prime of x is equal to f prime of x times g of x plus f of x times g prime of x. Okay, and I want to do that at 2, so that's f prime 2, g of 2, alright, so time for math. F prime of 2 is equal to 2. G of 2 is 3. F of 2 is 5, and G prime of 2 is also 5. So it looks like 31. Here, let's see, the chain rule, h prime of x would be equal to f prime of g of x times g prime of x. That's the derivative of what's inside right there. So h prime of 2 is equal to f prime of g of 2 times g prime of 2. So g prime of 2 is 5. G of 2 is 3. And f prime of 3 is 5. A lot of 5s and 2s and 3s in that table. Quotient rule. At low, D high, minus high, D low, all over low, low. So h prime of 2 is equal to g of 2 times f prime of 2 Alright, so let's fill the stuff in. G of 2 is equal to 3. F prime of 2 is 2. F of 2 is 5. G prime of 2 is also 5. And then G of 2 is 3. Oh, that's 6 minus 25 is negative 19 over 9. That's what I'm getting. And a few tangent lines here to finish up. This is how we find them in point-slope form. You need a point, and you need the slope. Alright, to find the equation of the tangent line to this at the point 2, 8. So I've already got the point, so that means I'm already going to have y minus 8 equals some number times x minus 2. How do I figure out what that number is? I find the derivative, and I plug in 2. So I know what the slope is at this point. So plug 2 in there, 12 minus 2 is 10. Find the equation of the line at normal. The word normal means perpendicular. So I know my slope was 10, so perpendicular to that is negative 1/10. That's how you perpendicularize a slope. You flip it over and slap a negative sign on it, or take one away if it already has one. We're going through the same point, so y minus 8 is equal to negative 1/10 times 10, times x minus 2. Only thing that changed was the slope. For what x value does the graph of f of x equals x squared plus 4x have a tangent with a slope of 6? Well, if I want a tangent line with a slope of 6, that means the derivative has to be equal to 6. That happens at x equals 1. And they're saying for what x value? For what x value? For that x value. There it is. Find the equation of a tangent line to this that's parallel to this. Well, let's see. If I get this into the right form, 2y equals 6x minus 8, and then divide everything by 2. Like that. Parallel to means has the same slope as 3. So we want the equation of a line tangent to this that's parallel to that line. Okay, so I need to figure out where this has a slope of 3. So f prime of x is equal to negative 2x minus 5. So I want that slope, negative 2x minus 5, to be equal to 3. When I add 5 over here, I get 8, so x is negative 4. And now I need the y value. If you think about what our equation, what we need to write our equation, I need y minus y value is equal to slope times x minus the x value minus negative made plus. And now I need the y value. So I'm going to take that x equals negative 4, plug it in here, I get 8 minus 5 is 3. And last one. Nope, just kidding. Second to last one. I'm on 29 now. At what point does this have a slope of 4? So the slope of this is 6x minus 2. You want that to have a slope of 4. That happens at x equals 1. Seems like the same question as 27, really. 30, find the equation of a tangent line to this through the point this, and use your local linear approximation to estimate this. Okay, so let's just find our tangent line first. Alright, so there's my point. Y minus 6 is equal to whatever the slope is times x minus 1. And to find the slope at the point where x is 1, I plug the 1 in here, get a slope of 5. And if I want to use that to approximate this, I'm going to add the 6 to the other side. 1.1 minus 1. There you go.